Hello students, in this video we are going to start here the second unit, that is process management. So in this we are going to study the basic things of process. So first we will see what do you mean by process or how we are going to define the process. So in last class, in last videos we have studied what you mean by process. So what do you mean by process? A process is nothing but a program, still it is in a execution mode, or you can say a process is a program in execution. Okay, or you can say it is an active state of a program. So here the program is different and the process is different. The process is the program in execution, still which has not completed its task, you can say. So for example, the examples of processes, you can say you have opened the MS Word and still you are typing, and you don't have finished your typing work, you can say. Or for example, if you are running any C program or C++, that is nothing but the process, you can say, means still that program has not yet displayed the result or output, you can say. So already we have studied that the operating system is going to support for the resources like memory, input output devices, and the processor. Okay, so even the process needs the certain resources including our CPU, memory files, and input output devices to perform the certain task. So now whenever we are going to load a program into our memory, it becomes a process. Okay, so whenever we are going to load our program into the memory, it becomes a process. So a process can be divided into a four sections. Okay, so whenever the program is going to be loaded into the memory, it is going to become a process. So now how we are going to draw, or how we are going to assume the architecture of a process. So here this, so on this slide we are going to, we can see here there is a diagram of a process in memory, or we can say an architecture of a process. So in this block, in this rectangular box, we are having the four sections, that is stack, heap, data, and text. Okay, so a process in a memory can be divided into four sections, or you can say four components, that is stack, heap, text, and data. So what do you mean by stack here? So a stack may contain here the temporary data such as methods. So method is nothing but the function. It contains the temporary data. It contains the temporary data. So which type of temporary data it going to have? It may have the function parameters or methods. So method and function both are similar here, and the return addresses and the local variables, you can say. So now coming to the second component or the second section of a process in memory, that is heap. So heap is what here? This is dynamically allocated memory to a process during its runtime, or you can say it allocates the memory during its execution. So execution means in its runtime. So it allocates the memory which may be processed during its runtime. So if is what? It dynamically it allocates the memory to a process during its runtime. So one more thing, if you are allocating the memory during the runtime, that will be called as the dynamic allocation. Remember, whenever we are allocating the memory during its runtime, that will be called as the dynamic memory allocation. Clear? So now the third component is text. Okay, so text is what, or what type of it going to have here? It includes the a current activity represented by the value of the program counter. So text means what? It includes the current activity represented by the program counter and the contents of the processor registers. Okay, text, it includes the current activity which is represented by the program counter, and even it contains the processor registers. So what do you mean by here? program counter. Text means what here? It includes the current activities. So current activities of what? The current activities of program counter or the value of the program counter. So what do you mean by program counter here? Okay, so program counter is what here? It is one of the register which is going to hold the address of next instruction. Suppose we are executing the current instruction, so after execution of that current instruction we need to go for the next instruction, right? So that will be indicated by the program counter. So what we mean by the data here, it contains the global and static variables. Okay, so data, it contains the global and static variable. So this is how the architecture of process will go. Okay, so stack is there, if is there, data is there, text is there. So stack is going to store the temporary data. So what are the temporary data? Your function parameters, return addresses, and the value of local variables, or you can say the local variable. So heap is what? During the runtime, during the whenever the process is going to starts run, it has to allocate the memory. So that will be done by the heap. So data is, it contains the global and local static variables, and the text is what here? It includes the current activities. So current activity of what? Current activities of the program counter. So what is program counter? Program counter is a register which helps or which points to the next instruction. Okay, so now we'll go for the differentiate between the process and program. So here on slide you can see here. So there are 5 differences I have written. So the first one is nothing but the definition of process and program. So process is nothing but the process is what? A process is a program in its execution. Okay, the process is an instance of an executing program I have written here. Both are the same here. The process is a program in execution, or even you can say a process is an instance of an executing program. So what do you mean by program? In a program, we already know that program is nothing but the set of instructions designed to complete a specific task. Okay, so now the second difference is the program program is a passive entity and process is a active entity. Okay, so process is an active entity because it is an instance of executing program and perform the task, and program is the passive entity as it does nothing until it gets executed. Okay, second difference is what? A process is active entity. So why it is an active entity? Because it is an instance of executing program. Why it is active? Because already it is doing its execution. So hence the name is a active. So what do you mean by a passive here? So whenever we are going to load, or we can say the nature of a program is a passive, because it does nothing until it gets executed. The program we have stored in our computer, but we don't have started the executed. So that is nothing but the passive. Okay, the program is a passive because it is not doing anything until we gets execute. Clear? So now the third is the process has the high resource requirement, like our CPU, memory, address, input, output. Okay, so program does not have any resource requirement because it only needs the memory for storing its instruction. That is nothing but the program. A process has high resource requirement and the program is going to have the less requirement. So process is going to have high resource requirement like CPU, memory, input, output, etc. So program is going to have only a memory requirement just for storing its instruction. So now coming to the fourth difference, a process has the limited lifespan. Why? Why? Because it is created when execution starts and we are going to terminate its lifetime, or you can say it is created when execution starts and terminate as execution is going to finish. Clear? A process is going to have a, a less lifespan, or you can say a limited lifespan, because whenever we will create the, or it is created, a process is created when execution starts, and it is going to terminate its process whenever it is going to finish its task. So now program has a longer lifespan because already we are going to store it in a secondary memory forever. Clear? A program is having the longer lifespan because it is stored on disk. Okay. So now one more thing is the last one. A process is going to have the certain control block, that is PCB, that is nothing but the process control block, and program is not going to have any control block like PCB. The process is going to have the control block called PCB, that is process control block, and similarly for program it is not going to have any control block. Okay, so for today only we are going to discuss this much, and remaining things we'll see in next video. Thank you.